Thanks everyone for the introduction. Let me present remotely today. I'm going to talk. I'll skip over some of the overlap with the prior two speakers, but I think I have some alternative thoughts on, especially the clinical use cases and clinical translation of these models and how that can fit into credibility. Of the 10 rules that Pete mentioned at the beginning, I think the three that I'm going to focus on today are using conceptually appropriate data, evaluating within that context, and then getting independent reviews. I think these are, to me, three opportunities that could have a really big impact in an open source ecosystem like we're discussing today or this weekend. I think that this leads off of the last session. I think that a big role that the ecosystem can have is helping to curate resources that may be used for establishing credibility, because those kind of the curation of resources and the development of data sets is often from groups that are not the modelers. So I think having an ecosystem that can connect those groups is really important. I'm going to focus on 3 or 4 bullet points. So I think when you have well-documented comprehensive experimental data sets, I think we also need to have large data sets. I think these 2 bullet points, we can develop really nice specimen-specific models with really detailed data and looking at multi-level. But I think there's also a big benefit in modeling for population-wide cohort models, where we can look at the effect of a particular surgical variable of interest or implant design parameter in the context of the variation in the population. I think that's a really great use of models. It's something that my lab does quite a bit, because those big data sets they're still hard to get experimentally, and the patients and the tails of distributions are often the ones that have the most challenges that we need to study. I think we need to have diverse and well-documented real-world data sets or clinical comparators for use for various contexts of use. I think this third data point is probably one of the hardest to collect, so it's something that maybe the ecosystem could help facilitate. And I think we also, another opportunity is a community for providing feedback between developers and end users. We heard a little bit about that in some of the previous talks, so it's a bullet point that I want to bring back up this afternoon. All right, so this first one. So there are a lot of well-documented data sets, OpenEase being one of them, that exist that we can leverage as examples. These data sets should really include detailed boundary conditions, anatomy, joint and tissue level measurements. And as Richard just talked about, there really needs to be quantification of measurement uncertainties. He mentioned, in-strong compliance. I think one of the things that we have a in vitro robotic system in my lab, and one of the things that I've really taken from Rob Colburn at Cleveland Clinic is that if we prescribe a laxity test with a certain trajectory, we need to report how well our robot actually matched that trajectory, rather than saying we followed this path. I think that's a really important component that needs to be included in experimental data sets, just like we're talking about sensitivity analyses in experimental or in computational models. And then I have a dot because there's a lot more that we could discuss of things that should be included. I also think that we need to have specimens from different injuries, disease states, equal representation of sexes, and then ranges of ethnicities, races, cultures. Because if we look at, there's been a lot of work with orthoload, for example, validating models that we then looking at a native knee off of a total knee replacement. I think there's just a little bit of a mismatch there about what we can actually interpret from models like that. So if we want to study something in the OA knee population, we should probably have OA knee data that we're validating our models against. So that's something that my group is working on, for example, is we've developed thoroughly validated our robotic superposition testing, and then we're working on generating a data set of joint and tissue level biomechanics for knees with varying levels of OA severity. This is kind of an ongoing project that we have in lab. We're looking at a range of flexion angles, 3-degree of freedom of joint testing, and we're running standard superposition workflows, but we've done some improvements to help account for our robot compliance and make sure that we're minimizing the errors and tissue level loads that we're reporting. And so we're working on publications right now to put out variations in our joint kinematics, kinematic kinetic relationships, structure function relationships, and ligament tension profiles. We move on to this next data point, large data sets. To my knowledge, it sounds like there's some in the works. It was great to hear in the first session some of the gate data, harmonizing gate data opportunities. So I think there's like OAI, for example, is an amazing data set of imaging data. There's some mechanics in a subset, but there's not really large comprehensive data sets that I'm aware of that couple structure and function in different disease states. So I think we really need to have sufficient data points in these validation data sets to be able to capture variability of our population of interest on top of the other standard data points that we want. In my group, we often we like to generate virtual cohorts, and in order to account for the fact that we don't have these large data sets, we often use statistical measures to help to give ourselves some credibility that a virtual cohort is representative of the population we're interested in. We often use tolerance intervals to estimate population bounds and then do some filtering. So for example, in this case, we'll vary ligament properties beyond what we expect the population to be. We'll run a series of different trials. We'll output some biomechanical measures of interest, and then the approach that we've used in the past is a Monte Carlo filter approach, where we from experimental data that's not a large data set, we define some kind of tolerance interval prediction limits to bound our probabilistic models, and then that filters out models that are not realistic. And then we have a subset of models that are in range of all of these parameters of interest, and that's what we would use for our virtual cohort. It's certainly not perfect, but it's the approach that we've done. Having a robust, large data set would be a lot better than this approach. But we've shown that this is effective at having overlaps of probability distributions. So we're not confident that any one model is represented necessarily of a specimen, but if we look at trends, for example, from cadaveric data shown with the data points and error bars and probabilistic modeling study, we see that our probabilistic model is representative of the trends we see in our experimental data. So moving on to real world data sets. So Jeff can speak to this as well. I know he's done a lot of work in this area, but I think that real world data is really important, because if we validate our model against experimental data, we can show correspondence in strain stress profiles, but that doesn't necessarily mean that our model is going to predict the clinical challenges that we want to address. So this is a nice paper that I've referenced here that that looked at combining both the experimental validation to be able to be confident that your model is predicting reality, but then also including real world data to make sure that, for example, in this tibial tray example, that if the crack's initiating at this posterior aspect, this posterior corner of the implant, that you should have a max stress in your model at that location. You shouldn't have a max stress up here at the anterior part of the implant. I think this extends to lots of other clinical parameters that we would want to study. I think validating with real world data is a really important component. And this real world data is hard to come by, so that's somewhere where the ecosystem, I think, could help out quite a bit if we as a community can develop robust real world data sets. One of the things that my lab is focused on is we're developing some translational sensor technologies to be able to measure in vivo joint and tissue level biomechanics that we hope in the future one of the applications would be to enhance these real world data sets, because we focus on having our technology sensors be very translational so that they can be measured in vivo with relative ease. And lastly, I think something that the ecosystem can really help with is providing a community that developers can get feedback from end users. So Snell mentioned at the beginning, they talk to a lot of people. My lab's gone through the National I-Core program, which is for those who are not familiar, it's a discovery process where you identify you have a technology that you're interested in commercializing, and you go out in the real world and you ask people about what their needs are. And this discovery interview process is a very structured process. Um, I thought I had a big network of people, and it's like, oh, getting 100 interviews is going to be no problem. But it turns out to be extremely challenging, and your Rolodex disappears really quickly. And you, at least for our case, we were far from our 100 after I was out of people to bug. Um, so I think if there's a way that as people are going out, as our community is going out and asking end users questions, if there's a way to document those, some of them obviously would be, if it's a technology development that you're working on a spin-off, you can't share that information, but there's probably portions of discovery interviews that could be shared. And so having a place where we as a community could share those sort of connections about what are the needs, and what are people actually, the end users, looking for in this case, credibility. What does a clinician actually need in order to trust your model output? We could fill in the blank with what does this person, this group need for wanting to use your model. So I think there's some opportunity there to have a central repository of these database of discovery interviews, or even potentially, generating lists of people who are willing to talk to each other. People sign up like, yeah, I'm willing to share my insights on knee arthroplasty and what are the pain points that I think a model could help with. So these are the 4 bullet points that I think would really help to establish credibility within this ecosystem. And so with that, I'll wrap up, and I'm happy to take any questions.